Well, thank you all for being here today for the first session on checking and validating AI and human claims. I'm Chris Alpe. I'm the Associate Dean of Libraries and Information Sciences here at Mount Sinai. And this is a question that kind of comes up all the time in the library about, I see these things and how do I find out if they're actually representing what's going on in the literature? So I'm very happy to be here with you today and partnered with my colleague who will introduce herself.
Hi, everyone. Welcome. Thank you for joining us today. My name is Marta Kordkowska. I'm the Director of Educational Technology and Strategy, and I'm really excited to chat with you on this topic.
All right, so what we're hoping to accomplish today is, first of all, to just get our heads around the common sources of error in claims, whether they're human authored or AI generated. You, as authors and scholars, do have very specific responsibilities regarding content accuracy and citation integrity in your scholarly work, whether that's articles or grants or anything that you're producing. So we want to make sure that there's shared awareness of that. We're going to introduce some tools and data sources that you can use to verify claims that might be challenging. And then we'll show you some applications of methods that you can use to check and validate and maybe even correct some claims that aren't quite what they were meant to be. Okay, so let's get started. So why should we check on claims? And if you go to if we look at the next thing, frankly, claims are super common in our scientific lives. They're very common in grants. Our National Institutes of Health grants actually have a significance section, which is almost entirely full of claims. Why is this important? Why should we spend money on this? Why should we do this work? And you don't get a lot of space to do that. As I'm showing you an example from a funded National Cancer Institute grant on the right that is part of the grant writing samples that NIH makes available. So this is a successful grant, a successful significance, and these kinds of statements are just very common. When you go over to the literature side, the structured abstracts, here's my objective, here's my methods, here's my results, here's my discussion. You really only get one or two sentences in that background or introduction or objective part to make your point about why your research question or your hypothesis or your objective is important. So it's really short. And then, frankly, as people's article lengths are getting shorter and shorter, the introduction is short. Many publishers actually have very kind of strict space limits for how long of an introduction to get to write. So everybody's trying to make really strong claims in a very tight amount of space. And we're going to talk about that today. But the library has always been very encouraging, obviously, as a place to read the literature. And reading the literature before you write up your idea is intended to kind of give you exposure to diversity of thought on a topic, right? When you're doing a dissertation or a thesis, you're writing a whole chapter of a literature review because they expect you to know the literature that's in pros and cons and what else is going on. And sometimes we'll get to this on the next slide, that it can be hard to represent the diversity of the literature, the diversity of the scholarship in this limited space environment. So before we dig in, I want to just point out from the International Committee of Medical Journal Editors what they have to say about this. So the introduction, we just talked about, it's short, right? We're providing context. You should only be citing directly pertinent references. So that means that like your claims and the references supporting them are supposed to be right on target. But then the references themselves, you can see they say they should be direct references to original sources whenever possible. So if there's a lot of literature to review, you'll have that question of, can I use a citation to a review article versus all of the original research? And we'll talk about that a little bit later. Referencing AI-generated material as your primary source is actually not acceptable, and Marta's going to talk a lot about AI-generated material today. But ultimately, we as authors are responsible for making sure that the references that we cite support the associated statement and that the references are actually correct. You can read a little bit more about that on the ICMJE site, but essentially those are the two things that I'm assuming we're all bought into today. We're bought into the fact that any claims that we're making or that we're judging that other authors have made support what we're doing. So if we're all on the same page, then we'll go ahead. And this is an example of me trying to practice what I preach, right? So I was going to make a claim to you that incorrect referencing happens in the literature all the time, and that people use a reference to support a claim and it's not actually supporting the, if you actually went and read the original article, it's not really fully supporting what they said. I was just going to tell you that that's a problem. And then I realized, like, no, I actually have to prove to you that there's literature that someone else says it's a problem, right? So this is a paper called The Virtues of Correct Citation from some of our colleagues in Germany, where they actually looked at other people's studies that had checked the references, both were the references accurate, meaning, was the title and the journal and all of that sort of thing accurate, but also this issue of, did it actually support the statement made in the article or only partially support it, right? And you can see in the table on the right that in these references, where you see some of them had small numbers of references, right? But some of them had thousands of references. And in the thousands of references, Cochrane review, for example, 20% of those almost 4,000 references didn't actually fully support the claim that they were being cited in honor of. This is a 2011 paper, but we will just talk about that even going forward. So here we go, right? So what leads us to this problem? Efficiency, I think, is a number one thing. A lot of times the introduction is the last thing that you're writing. You've written up your study and you're like, oh, wait, I need to put that I need to set up the introduction to fit whatever journal I'm going for. Sometimes you've sent your article out for review and it's the reviewers who say, you need to actually provide a citation to support that claim. And then you're really in a hurry because you're like, I want to get back to the reviewers. I want to get published. And at that point, it's really easy to fall into the kind of thing of, I'm only looking for or selecting supportive literature, or what some people call cherry picking, right? I'm not looking to see what the actual literature says. I just know I want to say this thing and I need a citation to support it. And then you get this problem called confirmation bias and confirmation bias comes in a lot of different other flavors for epidemiology. But in this case, in publishing, I'm talking about it meaning you're only looking at literature that supports your point of view because you started your search for that saying, I need something that supports this claim, right? Going back to what we learned from the medical journal editors, though, if what you're doing is citing a review article to support your claim, then you are kind of depending on the author of that review article to have accurately represented the primary literature for any of the statements that they've made in their review article. And that can be problematic because maybe there's 18 papers that are seeing one point of view and 2 that are seeing the other point of view. If that review article only talks about the 18, the predominance of the one view and not the other, and you're relying on the review article, you may miss the fact that there's actually another point of view that may need to be represented. And that's why the medical journal editors say you should kind of focus on the primary sources. And then the fair thing is, if you don't find an article that exactly makes your point, and you probably won't because otherwise, why are you doing new science? How do you interpret that without totally distorting the original author's meaning? So these were all problems before AI became part of the mix. But now, if you're using generative AI tools to help you review or summarize the literature, it's going to be more complicated, right? So I've just put in the text in italics here a prompt for if I had been not looking for that article myself, but trying to ask generative AI to help me find something to support my claim, right? Find me an article about why we should study errors in this and use it as evidence to write a short introduction and give the article citation in Vancouver reference style, right? And 100% my chatgpt.edu account did that. But I have to check, right? Is the citation to a real article? And does the sentence actually reflect what was in the article? And that's on me as an author to do it. And so these are just a couple of fun examples that I will share that as I was going through looking for examples to give you about authoritativeness. I was talking about the fact that I think consuming cheese can give people headaches. And I want claims that explain this, right? So I asked the search engine, I'm not going to name which one today, but I said, show me the answer to this question about cheese consumption and headaches. And it happily gave me this dialogue and 5 references. And when you go to the first one, which is a very reliable Tufts Health newsletter, right? the evidence in there is just a quote from, and I don't mean just in a bad way, but I'm saying the evidence here is just a quote from a clinician saying certain foods can cause headaches, and examples include aged cheeses. That's, so you have this conversation with yourself. Is that exactly associated? Is that all cheese consumption? Is that just aged cheeses? You have a lot of, you have a lot of questions. So I asked it to be a little bit more focused, and then it gave me cheese consumption associated with headaches, though not scientifically proven to cause migraines. Okay, that's very specific. And it cited this paper on cheese consumption and multiple health outcomes, which is a real paper, but doesn't actually talk about cheese consumption and headaches in its big table of outcomes. So, anyway, with those all as your starting point caveats, I think we will now switch gears to like how is it coming up with that?
Yeah, so I think we have to get a little bit technical. And I think it's understanding a little bit about how generative AI works. And some of us may have heard this, right? Generative AI works in a way that it predicts the next word within a series based on what has come before. It's almost like predictive text on your phone, or something to that effect. But it's not so simple. So for this example, it's a beautiful day in the most likely word that would come next would be neighborhood. But the way that AI really sort of processes that or creates that content is looking for patterns in the data. And so one way is training data. So it uses massive amounts of text from books, from websites, and other sources in order to say, okay, what's the most likely scenario here based on this context? In some cases, it's also looking at specific, maybe networks that have been created or transformers. So, what's the code saying to do with this information? When we look at feedback loops, we're thinking about how the model is fine-tuning based on feedback. So, you'll hear that the GPT was trained on something, or it changed its training based on something that was fed forward based on this feedback. So the next word would be predicted differently based on that feedback loop and what additional information was provided, and also probabilities. So, how likely, which is what you can see over on the right-hand side, is it that that would be the next word in a sentence like this? So, you see that there's not a lot of verification in between. There are some safeguards, but it's really based on linguistic models that are pulling from other areas and feedback. So, why do we see these errors, or as you may have seen them called, hallucinations with AI content? I think first is the predictive nature, right? So, rather than pulling entire facts and their citations, it's predicting the next word within that content. Next, we're thinking about the fact that it's trained on all available sources, not vetted. So you may have seen something on the internet, whether it be a meme or a blog or comments, right, from unverified sources, people just saying something. And so that data is available online and can be used within that large language model. Some of those errors also come from compression or a lack of evaluation of nuances. So the model has to compress a lot of data. So, right, as you can imagine, there are tons of sources out there. And so that model has to take the information that's out there and pull it into patterns and compress that data. So this often impacts complex topics, A, or significantly evolving fields, meaning where there's information that was, going one way at some point and then has now evolved to be something else, or something that's especially quickly evolving. There's no built-in validation. So we don't think of this like built-in fact checker. It doesn't generate a sentence for you and then check that for you against some information out there. And also connection to databases. So if the model is not connected to a database or verified specific sources, such as through custom GPTs, then it just pulls knowledge from any of that available content that we had mentioned previously. Okay, so those are some reasons why we might see errors or hallucinations with that AI content. So, what do you check, right? And there's different types of claims that you must appraise when you get them from AI or yourself, right? Essentially. So claims that you are generating. So these might include AI generated summaries of search results, and we're going to look at some soon, or AI generated summaries of articles or other content you provide to an LLM. It might also include claims that others have published. So citations that look strange or you can't find, a sentence, things that are claimed in a sentence, so sentence claims or quotes with a citation, or numbers that surprise you with or without a citation. And we'll also look at those a little later. So without further ado, I'm going to show you something you've probably seen many times before. So an AI summary of your search. So in Google, I added, how do you treat aphasia post-stroke? What you would see previous to AI was, a list of references or a list of resources. And I'm sure that you can think of a time that that has happened to you. Now with AI, at the very top, you get an AI overview. And that AI overview allows you to essentially have a summary of what was taken from other places. So here we have post-stroke aphasia is primarily treated with speech and language therapy. And then we also have some links. And so I know it's rather small, but I'm sure you've seen this. So at the end of the sentence or the paragraph, you see a link to that citation, and then you see those citations displayed on the right. So this in Google, this is powered by Gemini, and it synthesizes information from multiple sources. Again, not necessarily vetted sources, sources from multiple countries, for example. It does provide those links, but it's your responsibility to click on them. You might notice that some of that information is surface level and sometimes mixes with contradictory information. So, where one bullet might say X and be linked to that article, you might open that article and say, oh, wait, yes, there is that sentence. But the next sentence says sort of maybe the caveats or when not to do this. The pros of something like this is if you're looking for a complex topic or you just want a little overview, it synthesizes that complex information and provides you with this general overview or a big picture and provides the links to the resources, right? The cons are that it uses unverified information and causes a loss of nuance. So, like more big picture, especially if you're looking at medical information or maybe something that is more detailed, you could lose some of those nuances, some of those exceptions, some of those other categories, right? So, one thing we have to think about is okay, we could just take this at face value. And I'll tell you myself, if I look at something like this and I know the content, what I didn't tell you is in my previous life, I was a practicing speech pathologist. So I know this content. I'm like, ooh, this is maybe like, okay, close, but there's so much more to it. Or this is just one type of aphasia. But if it's content I don't know about, or I look up something that is completely new to me, then I might say, okay, well, I don't really know, this sounds good, right? So it's really hard to verify. So it's really on us to like really say, okay, I have to commit to verifying this and I have to know if this is really true because I Googled it for a reason or I looked it up for a reason and I want to know the right answer. And so again, we would go through some of these links. We would actually appraise the link, right? So where the information comes from. I think back to like my critical evaluation of research courses and think about what that could be at odds with, maybe go to find the link that has the highest authority, and so on and so forth. So we see this often. It's also something we have to verify. It's not always accurate. The next area we'll talk about is AI summaries of research articles. So this is one example where we have in ProQuest Central. So here I searched Mediterranean diet and cardiovascular risk and had an article come up. Now, for the purpose of space and time, I saved us the full explanation, but essentially what you could do is after you open the full article, on the right-hand side of your window, it displays this research assistant. And you could ask the research assistant anything about the article. So I did, what are the findings and conclusions? And so it provided me some of those findings and conclusions. And I pulled some of the highlights for you for the next step to demonstrate this. So the ProQuest summary of the conclusions told me that a meat-based diet, individuals who preferred a meat-based diet had larger abdominal circumference, and also that adherence to the DASH diet is significantly higher among individuals with cardiovascular risk factors. When I verified this using a prompting technique in using ChatGPT and then went and manually verified this myself through the article to look at those nuances, I I found some areas of disagreement. So for the dietary preference and health metrics, the meat-based diet had a larger abdominal circumference. In this article, there was no statistical significant association between dash score BMI or abdominal circumference. So that statement was very, right? It was a very strong statement, but there was no statistical significance. And then missed nuances. So in the purple, it says the DASH diet is significantly higher among individuals with cardiovascular risk factors. But if you look at the summary, it says the summary says adherence is higher among people with cardiovascular risk factors, but has a small effect size. And so that small effect size has a meaning, right? Or maybe we would be interpreting this differently. So again, missed nuances, maybe you'll pull the wrong conclusions, good overall, right, summary, but then moving forward to some of those missed nuances. And I'll pass it back over to Chris to tell you about some published claims.
So I think that one of the most famous areas of claims issues has been the citation issue, whether you're talking about the AI hallucinations or, frankly, talking about human error. When you are reading a paper and you do decide to take that time, make that effort to go track down the citation, and then you find that the citation isn't right. And so the article that we already were telling you about the value of citing, this was more information they had about going forward. How often do citations contain errors? And sadly, you can see here that on average, 16% of the citations were still containing errors, and that really ranged from a low amount in some journals to a very high amount in others. But the key takeaway here I want to point out is they say major errors which make it impossible to identify the original source were rare. So, they might have had like they messed up a word in the title or the page number, or, they inverted a number in the year or something. But if you were able to search the authors or the title or the journal or some combination of, you would eventually find this paper because it's a real paper. They've just messed up the citation a little bit. Whereas with the AI hallucinations, this data that I'm sharing here from a 2024 paper, right, that the hallucination most often happened with the keyword you were asking it for. So the example Marta was sharing about the stroke, post-stroke aphasia, that actually it's making up the reference titles and relevancy based on the keyword you asked for. So even if the article didn't have post-stroke aphasia in the title, it knows that's what you're looking for, and it's trying to please and predict. And I shouldn't say please because that's a humanistic thing that it can't do, but it's trying to actually find something that's predictive of what you're looking for. So it would make a lot more substitutions there, whereas the actual titles of the the journals themselves, it would be changing that less often because those journal names show up over and over and over in the literature. So the likelihood that it's going to predict the right journal name is much higher because it's seeing those more frequently. So I want to just give you, as I said earlier, we're going to talk about how do we check citations, how do we check sentences, and how do we check kind of numbers or statistical claims. So these are the three examples that we're going to work with. So I'm just introducing them here. You'll see them again as we actually go through how to talk about them. So here's a citation we want to check. Here's a sentence-based claim we want to check. And then here's a numerical or statistical point. So we can go ahead. And so we wanted to just introduce a few tools to you to get started. These may not be the tools that will match up with the specific examples that we're showing you today, although you've already seen ProQuest Central and the example that Marta just showed you. But if you have quotes and things that you aren't able to verify by doing just regular search engine searching and following the links, then these are kind of like this next level of high reliability knowledge resources that you can use. So we're assuming that when you first tried to verify the claim, your whatever your favorite search engine is, you're searching that sentence or you're searching that citation or you're searching that quote and you're not finding it, or what you're finding is not necessarily confirming what you had thought you were going to see. So these are three news resources: Nexus Uni, Business Source Complete, that have full text. So somebody in the text had asked, does AI only access open access articles? And that's what we were talking about. These are mostly closed access articles and news and other areas where you can search for it. Wait, did that quote really go with that person, or that claim that they were making, was that actually what was published in the New York Times, and things like that. ProQuest Central covers not just these news articles and resources, but also more kind of biomedical and nutrition and other kinds of health literature as well. It's a more all-purpose database. And then when you go on to the next, for the statistical and demographic questions, we aren't going to walk through using this New York City data or this global health data exchange, but given that we're here in New York City, a lot of the claims that come up that you might want to be looking at might be specific to New York. So we wanted to introduce this data resource to you. And then global health being so important here at Mount Sinai, especially for our Masters in Public Health program, wanted to call attention to the Global Health Data Exchange, because you may need a very specific resource that isn't public. It might be web available, but it's not getting crawled at the depths of all of the statistics within it to be able to just use a search engine to find it. You probably have to go and use the actual tool. But one that we will talk about today is using PubMed and its statistics or epidemiology subheadings to really dig into a question that's about a numerical claim that you need to validate. Okay. The last thing is that sometimes if you I keep wanting to say Google as the generic term for searching. As you've searched using a web search engine and you're looking for citations in particular, many of the citations will have a digital object identifier, a DOI at the end, or they'll actually have a website URL for the publication at hand. And if you search on either of those and you get kind of a not found, and you're like, well, maybe it existed at some point, but it doesn't exist anymore. These tools are really great for that because, maybe it is not an intentional error. It wasn't that they made this up. It really did exist at some point, but it no longer exists on the web. The Resolve a DOI can help you if maybe the publisher doesn't publish that journal anymore, and therefore the journal's not up on the web anymore, but you want to see if the DOI did exist at some point. Likewise, if you have a website address, the Wayback Machine from the Internet Archive can help you with that.
So Chris detailed some tools that we have access to at Sinai. I'm also going to talk about just tools generally. So Cite AI is not something that we have a subscription to at the library, but it is something that you can find on our LibGuide that we discuss, and we'll share that link before the end of today's session. But it offers a 7-day free trial. So if you want to take a look at how it works, you can. But Cite AI is an AI powered tool that essentially tracks citation contexts and actually gives you a little bit more information. It tells you whether that citation is supportive or contrasting or neutral. It tells you where it may have been found in the academic literature. So, for example, if you were looking at this article from 2010, you could you have all the information about who the authors were, the abstract, so on and so forth, and then you can click on cited by, and you'll see what section it was cited. So for this first one, it was cited in the results and it was supporting, and this is exactly where you found that supporting statement in that article. And there was another one that mentioned it with in the results section, but this was now more mentioning and less supportive, right? So it tells you distinguishes essentially those contexts. The other thing that it does, if you look at this next screenshot, is you can actually ask it a question. So their example was how many rats live in New York, and it provides you the information in prose, like the previous example I showed you from Gemini, and it provides you references on the right. But you can also click and get a little bit more of that information as to what was supportive, what was mentioning, and where it was in this pop-up over that citation. So you know that you can verify that information that way. Another thing we wanted to mention is using an AI detector. So often we get asked, should I use an AI detector for looking at AI work? And so there's another tool, but we would say it's likely not helpful, right? It's not validating your answers. It's just detecting whether or not this was likely AI generated or not. And it works by really looking at language patterns, not the facts. So it can't tell you something was false. It just says, hey, this language pattern, the way that this was phrased, seems to be the way AI would have written it. And it's been shown not to be super reliable. So the other tool you could use, and I alluded to it briefly earlier, was prompting. So for example, in a tool like ChatGPT or another generative AI tool, you can, after you've done something like, hey, here's this article, and here is the summary, right, that AI generated for said article, assuming that that article allows you to upload into AI. You could say, which exact sentence or paragraph in this article supports the summary point? So ask it to match the source. You can also ask it to compare two versions. So, hey, compare this summary to the original article. What important details might be missing or simplified, or a variation of this, right? Essentially asking it to check its work. You can also ask for exactly where this occurred, so then it's easier for you to go back and check. You could text for misinterpretation. So you could say, could someone misinterpret the summary and how? Or does it exaggerate or downplay the findings, right? If you're looking also at the original article. And then a prompt for summary expansion, expand on the summary point, but use data or information from the results section. So now we're going to move into the how.
So when you have those weird citations that you're like, is it real? Is it not real? How do I approach this? One of the tools that was in use well before was the PubMed single citation matcher. And we can drop that in the chat for you after this. And you can also see it here, which essentially allows you to kind of plug in those various pieces that we mentioned. There are plenty of tools to look up the DOIs, as we mentioned, because a lot of times you do have invalid digital object identifiers. All of these, and I want to say thank you to my colleague Tim Hayes in the library, in our interlibrary loan service, which is where we request articles for people that Mount Sinai doesn't have a subscription to. They often receive these weird citations that turn out to not actually be real citations, as well as addressing many of those error issues. So, unfindable journal titles, there are places that you can check, such as WorldCat, which is the catalog of most of the libraries in the United States and around the world. If a journal is a real journal and is subscribed to, you'll find out that it exists there. And then other hints that it might not be accurate really are around there's a mismatch between the title and the date. You know, for example, the example he shared here is COVID-19 articles that were actually published back in 1930 according to the publication dates and the citations. So some of them will they will jump out to you, but none of us are really subject matter experts. And therefore, if you look on the next slide, the example that I have us working through very quickly, you know, this might look like a strange citation, right? Or you can't find it. So you see that you have a couple of the authors are same authors, but different first initials. The topic of this, the biogenic Asian and cheese amount and factors, that doesn't match up very well with what might be a systematic review topic normally. Systematic reviews don't seem to normally happen so much about technical, kind of more food chemical questions like this. And then you might not be familiar with the journal food prod processed nutrition, and it's not included in PubMed. And so you might be like, I'm not sure that this exists. Um, so in this case, this is actually a real citation. If you plug it into your search engine, you'll see right away. But any of these elements, you could search on that DOI, for example, and any of the DOI lookup tools, and it would actually pass you to the full citation. You'd see, you could search on that journal abbreviation, see it's a real journal. So most of the things that you might have an index of suspicion about, if you didn't find it on the search engine, you could still very much catch this. So this is a perfectly good real citation. It just might have struck us as unusual. The sentence claim example here. So this is an interesting one. We saw that we were talking about cheese in general earlier, right? But now this claim says raw milk cheeses are more likely to cause headaches than pasteurized cheeses. And you search on that and you don't find any good evidence for that. All of the things in your search engine are talking about aged cheeses, and they're not making any kind of conversation about raw milk cheeses and pasteurized cheeses. There's no citation for it. So in this case, I just wanted to use an example so you could see Nexus Unity in action. So in this case, I literally pasted that phrase into the search box. You could also just do raw milk cheeses, headaches, pasteurized cheeses, and see where the words came up, right? And so if you look at the highlighted text down there, it's in an article called Foods That Can Likely Give Food Poisoning. And you see here the nature of that relationship isn't really anything about the cheese that's causing the headaches. It's actually them saying, raw milk cheeses might have listeria, and listeria can cause headaches. And so leaving out the part that listeria is the reason for the headaches creates a really different impression than just saying raw milk cheeses cause headaches, which might make you think there's something about the cheese. Okay, so this is an example here where that claim's not helping itself. It needs to provide more information for that claim. The last one is evaluating a numerical claim. And these, so this is an example from the grant that I mentioned. And it did actually, you can see from the references 14 and 15 there, it initially had references, but the grant sample online didn't provide those references. So I thought this is a good example for us to use as a check. So if you actually just search, estimated 102,000 obese women diagnosed with invasive breast cancer each year in the United States, the search engine kind of says to you, okay, the National Cancer Institute, that's a trusted source, right? Estimated that there were about actually 92,200 back in 2019. And so the link, that fact link that was there was for the fact sheet. So when you go to the fact sheet, there isn't this, you're like, okay, let me find the right section for this 92,000 number. The 102,000 number is not there. And it gives you this information. You see on the right, I should have circled it for you, that it says 92,200 new cancer cases in women. That's where it's pulling the number. But you see that it's pulling that from a citation of another study, which is number 45. And this is the citation for the number 45 study, which is actually an open access paper in CA, a cancer journal for clinicians. And if you're familiar with this, every year this journal actually does publish the annual statistics for NCI and the American Cancer Society in a special volume. This is not that special volume. This is a scientific article. But already we're backtracking now to literature deeper, deeper, deeper. And so at some point, if you're saying, I want to see about this 102,000, or I just want to find what the number is today, that's where I think if you go to the next step, at this point, rather than using a 2019 article, if I'm really trying to understand the estimated number of women who are diagnosed this way, I'm actually going to go to PubMed and do a search. And this is where I said those subheadings come in handy. So you can see here I've said, show me the papers about the epidemiology of breast neoplasms and obesity. Make both of these the major topic of the article. Add United States and make it show me the most recent things first. I could actually make this much more focused, and any of the librarians on this meeting would be happy to provide assistance with more strategies. But essentially, when you start to go down to this claim verification and older studies and older studies, it may just be a signal to you to want to search the literature again as well. So these are just some of the strategies and tools that you can use. So I think we're going to wrap up in the minute or two that we have left.
Yep. So discussion and takeaways for us today. To start, we wanted to share something that Harvard Business Review advises us to do, and we took some of the more general thoughts from it. So one is to watch for built-in biases, right? To think about how AI presents information and what it might forecast from or what data it might extrapolate from. Another is to not substitute discussion, right? Seek peer input, have these conversations, don't replace them with AI because there might be additional information that would be helpful to you. Think critically about every search or every ounce of information that you get. Make sure that you're not only looking at the bottom line, but evaluating how we got to that bottom line. And set clear rules for if you're working as a team, or if you're teaching a course, or if you're working on a research paper as a team, for how you use AI and build in some safeguards. So to wrap us up, some food for thought or some questions you might want to think about how to do this effectively or to essentially make it second nature, right? This verification, and how to talk about this with co-authors as you move through navigating this field.